Hey guys, welcome to this talk on Break It Till You Make It, which is on chaos engineering. And this entire talk will be based on chaos engineering and cloud native, and how you can mix the two together. And I'll also show you different tools, and one of the tools which is Litmus, which I work on. So who am I? My name is Sayan. I am a software engineer at Chaos Native, and also a co-contributor as well as a team member of Litmus, which is the cloud native chaos engineering toolkit. Now, the few agenda topics that I've mentioned today is what is chaos engineering, why would you need it, what are the problems, what is cloud native chaos engineering, what are the different tools in the market, and also we'll see what is Litmus. So what generally is chaos engineering? It's basically the practice of breaking things in production, but it's not just production. You can do it also in the ops. Like it's something that the ops team should do. You can also do it pre-production or also on your staging cluster, also on the dev side. Now we generally never like downtimes. Downtimes are really expensive, so we want to mitigate that. And chaos engineering is just a practice which helps you target your application and break it manually, so that you do not face that in the real event. So it makes your application more resilient. Now, we want to do the testing in mostly the right side of the DevOps loop. What we generally do is we mostly do it in the left side, where we have E2E tests, unit tests, and smoke tests, and all these different kind of tests. But we want to shift the idea to focus more on the right side of the DevOps loop. Now, typically, it's done via game days. We rarely integrate rarely integrate this sort of a system in CI/CD, and it's only specific to SREs as of now. The way chaos engineering is happening, but we want to enable more people out there to try it out. Mostly planning and execution is done manually, and there's no automation as of yet. And observability is not really something that comes pre-packaged when we talk about chaos engineering. So what is cloud native and cloud native chaos engineering? So cloud native is basically the practice of taking cloud computing and putting it a notch up by making things much more scalable, extensible, elastic, as well as flexible, when we're leveraging most of the concepts of the cloud computing and we're putting it up a level. So when we do cloud native chaos engineering, we focus on 5 principles, which is open source, and it should obviously have community collaboration if it's open source. The APIs and the lifecycle management should also be open. What I mean by that is, if you have any API and if you have any management set, which it should be flexible and open enough for any other solution to integrate smoothly into. The observability should be open, and you should not be scoped or limited to any certain monitoring platform. It should be open for any solutions to integrate into. And we also want to we highly recommend having GitOps as a part of the 5 principles stack of cloud native, because with GitOps you get a much more version control and like a task-based, versioning system, which helps your not just the dev team but also the ops team. Now, the different tools that are out there in the market currently are Chaos Blade, Chaos Mesh, Chaos Toolkit, and much more. But these are doing a similar approach like we are doing in Litmus, so which is enabling chaos engineering on top of Kubernetes. But they are great tools, but not one tool can be perfect. So all of them have their flaws, and a few flaws that are currently there in the market is some of them may be very good, but their market is only scoped to a certain area, and they have a limited set of documentation, a limited set of very good documentation, but limited set of languages. So the availability is not that high. Some of them have very good dashboards, but they are not really very secure. And some of them do not support data scheduling or are not really portable. So what we tried to do with Litmus is we tried to incorporate all these 5 principles of cloud native chaos engineering, and we as you can see, all of them are ticked. So we tried to mitigate all the problems, all the issues that were there in the other tools and that were there in general in the market, and we were successful in doing so. So what is Litmus? It's basically a cross-cloud chaos engineering toolkit. It started out as a toolkit. Now it's more of like a framework, because you can integrate it with anything, and it helps SREs to add this particular solution in their own enterprise requirements, and then induce chaos with the help of this toolkit. And then you can create workflows with multiple number of chaos experiments, and this set of chaos experiments which turn up to be workflows can be induced on your application to check the application's resiliency. So what I mean by that is, let's say you have experiment A, experiment B, and C, which might be anything like killing a pod or killing a container, and you can chain all of them in certain order, whichever you want. And if you induce chaos on that, and there's two concepts of steady state and hypothesis. So if your steady state is, let's say, everything is working fine, and your hypothesis is, I would want to kill this particular container or particular pod, and I want them to be back up again. That would mean that if they're successfully back up, then that means your system is pretty resilient, and your chaos injection, the idea was perfect. So upon the hypothesis, you should reach back to your steady state. So that would mean that your chaos experiment or the entire idea was pretty good, and your application is resilient. So that is what you have to keep in mind when you do chaos engineering, and Litmus enables you to do all those things. So moving forward, we have a list of experiments, which is, we are proud to say that, which is pretty high than all the other toolkits or tools available right now. So we have a lot of experiments which are both Kubernetes specific as well as non-Kubernetes, and these are the main chunks of pod chaos, node level chaos, network level, or stress, or even cloud chaos, or even application specific chaos. Like you can induce chaos in, let's say, Cassandra, Kafka, OpenEBS, or any other application. This is the public chaos hub that I just told you about. This is called Litmus Hub. Chaos Hub. So a public Chaos Hub would already be integrated when you install this particular tool, Litmus. And there's also an option to install a private Chaos Hub, which is, let's say, your application, your enterprise has a certain requirement which is private. Then you can also create your own charts, and then you can integrate them into Litmus. Now, Litmus can run both on cloud as well as on-prem setup, and it can also run on VMs as well as bare metals. And it is wrapped entirely in Argo series, so whatever you do would have a beautiful visualization, as well as you can export metrics out of it too. So if you are using your own analytics solution, you can clearly export the certain chaos resources that were created as a part of the chaos injection, and you can pull those metrics out to your own analytics solution, and you can monitor the same. You can use your own observability. So typically, it is not just scoped to the ops team, like I mentioned before. We want to enable more people, more personas out there, more developers, more DevOps people to try it out. So it's not just scoped to SREs, which is why we have chaos in CI pipelines too, which is when let's say a developer is setting a PR or doing something in the CI pipeline, you can induce chaos there as well. And we have 4 different templates, which is GitLab, GitHub Actions, Spinnaker, as well as Captain. So you can use this particular sort of template, which we call as a chaos stage, which is let's say you have application A and chaos pipeline in the flow. There's a flow A and there's a flow B. So you can integrate this chaos stage in the middle, and that would actually enable you to add certain experiments, certain chaos experiments that you want to do, maybe a pod delete, maybe a node level experiment, and you can add these experiments in sort of sequence in the GitHub action or something, and that would be actually executed in your CI pipeline. So it makes things much more easier for developers too. And if you have a staging cluster or pre-production cluster, then of course you can install Litmus in there as well, and then you can try the entire flow out naturally without having to do it in CI pipelines too. And also for Kubernetes versus non-Kubernetes, you can induce chaos in non-Kubernetes cloud providers as well. So you need a network access control API, which then induces chaos on, let's say, AKS or EKS or GK, or even VMs for that matter. So you can see VMware. So there's an experiment of VM power off as well, which powers off your VM. So that is done natively on VMware. So you get all the certain capabilities with Litmus. And yeah, that's all about cloud native chaos engineering, and about the product Litmus, which you can use to do cloud native chaos engineering. Thank you.
Awesome. Thanks for the talk. Yeah, so that was really good. You kind of described the general idea of chaos engineering and of Litmus. Can you keep your presentation open if that's okay?
Sure.
Yeah, so I was wondering, where would someone start with chaos engineering? What are the first kind of things they should do to start down the journey of chaos engineering?
Well, in the initial stages of chaos engineering, what they can do is they can start off with like creating certain pods in your microservice architecture, and then just particularly trying to delete pods. That is the standard experiment. And there's also something like very default, de facto. Experiments which are sock shop as well as potato head. So these are all part of CNCF. So
Okay.
if you want to just start out, then you can try out sock shop, or you can also try out potato head. So these are very sock shop is like an user facing e-commerce sock selling this application which is just done for demos, and so is potato head. So you can kill individual pods, individual containers as you wish. That will give you a general great idea about chaos engineering.
Okay. And is there any scope for doing this without like a virtualization setup? Say if you have set up with bare metal, is there any advice you would give for doing chaos engineering with that?
Yeah. So all you need, if you have, let's say, a Minikube or K3s or even kind cluster set up in your system, then that is perfectly fine. You can run it at the bare minimum of 2 CPUs and very low memory requirements. So you can just install Litmus on top of that, and you can create your own chaos in your dev cluster. So that would be perfectly fine. So you don't
Oh,
need a
okay.
full blown setup to do that. Mhm.
Yeah.
Yeah.
Okay, that's very interesting. I suppose one of the very important things about chaos engineering is the outcomes. How do you measure the outcomes? Like, what are good measurements of outcomes?
Okay, so with Litmus, Prometheus is already integrated. So when you install Litmus, you get Prometheus along with it. And when you enable this particular monitoring setup, you also have Grafana, which allows you to view this all different metrics that we do when we use Chaos. So there's also one of the CRs that we use called Chaos Result, which is integrated with probes as well. So probes are like pluggable checks in your system when you want to do some chaos engineering. So let's say HTTP induce HTTP chaos or CMD based chaos or something you want to run in the batch while you do so. So whatever kind of chaos you would do, we this chaos result CR would always pick it up, and that would generally give you a verdict of how the experiment passed or not, what actually happened. And also these metrics that are generated as a part of chaos, you can also view it via Grafana, and you can see the spikes going up and down. And also if you click on that, it'll also show you this particular CR, the chaos result, in a verbose manner. So with the help of that, you can of course understand, and also you get logs as well on the UI, so that helps.
Okay, yeah, that makes sense. I suppose a sort of pseudo question from the chat is like, do you have a way of simulating a cat walking across your keyboard with a root open shell?
No, not as of now. We'll work on that.
Yeah, actually another question just came in. At what scale do you need to get meaningful measurements without too much risk of regularly taking down prod? Tens, hundreds?
Yeah, so generally what we do is we have a very basic two-node cluster which is running out there, which is the standard DS2 VM, which is the very basic VM, and we keep it running, and we just do a recurring schedule. So let's say we just run a cron workflow, and that keeps running on our system, on our pre-production cluster, and then we just try to induce chaos on our own pods that we use. So that way we see in case of new release changes or GA builds, if something broke or not in our production setup. So yeah.
Okay.
At a basic level of PS2 VM, you get a pretty good amount of chaos injected. But let's say you want to do crazy things, you want to add multiple parallel experiments or do a lot of sequential experiments, you would definitely need more memory.
Okay. So is there any minimum you would recommend in terms of instances or resources?
Minimum is one node, 2 CPU cluster. That would be fine. With a 4 GB RAM, that would be pretty good.
Okay.
Yeah.
Well, thank you so much for today. Up next, we have Kilian Valkov, who will be talking about the prefers reduced data media query, which is due to come out very soon. It's making the world a little bit more accessible, and we're going to hear more about it. So thank you again, Sayan, and I'll talk to you again soon.